So today we are going to start up with the last subunit of third unit, that is precipitation titration. In the last lecture, we have finished off with complexometric type of titration, that is definition of complexometric type of titration, basic principle of complexometric titration, types of complexometric titration, metal indicators used in complexometric titration, what are the ideal requirements of metal ion indicator in complexometric titration, and estimation of drug substance, that is calcium gluconate and magnesium sulfate. Today we are going to cover up the new chapter of third unit, that is precipitation titration. It is also one of the type of volumetric analysis. And precipitation type of titration is particularly done for the drug substances that contains metal ion in it, say for example chlorine, bromine or iodine. So most preferably precipitation type of titration is to be done for the drug substances containing halide ion in it. So points to be covered under this chapter is what is Mohs method, Wohlhertz method, modified Wohlhertz method, Furjans method, and estimation of drug substance, that is sodium chloride. So these are the points to be covered under precipitation type of titration. For any sort of volumetric type of titration, firstly we are going to study definition part, followed by basic principle, followed by indicators used in that type of titration, and nextly estimation of the drug substances. So firstly, we will study what is precipitation titration. The name itself indicates there is formation of precipitate between standard precipitating reagent and analyte. In case of precipitation type of titration, the analyte will be halide in nature. And lastly, we are going to add indicator to the analyte. So depending upon the use of indicator, this precipitation type of titration is categorized into three classes, that is Mohs method, Wohlhertz method and Furjans method. So firstly we will study definition part and introductory or basic principle part of precipitation titration. So precipitation titration is a type of titration which involves formation of precipitate during the titration technique, and this precipitate is formed between various precipitating reagent, and most commonly used precipitating reagent is the silver nitrate. So if we are going to use silver nitrate as a precipitating reagent, then that type of precipitation titration is also known as Argentometric type of titration. Other than silver nitrate, ammonium thiocyanate can also be used as a standard precipitating reagent. So in case of precipitation type of titration, we are going to use two standard solution of precipitating reagent, that too silver nitrate and ammonium thiocyanate. So these standard solutions we are going to prepare. Nextly, we are going to fill up the standard solution into the burette, and we are going to add 1 ml of standard solution to contents in conical flask containing analyte. Here the analyte will be the halide, that is in conical flask. It will contain aqueous or solution form of analyte. Nextly, if any extra reagent is required, and lastly we are going to add indicator. Depending upon the nature of indicator, precipitation type of titration is categorized into three classes, that is Mohs, Furjans and Wohlhertz method. So what is precipitation titration? It is a type of volumetric analysis which involves formation of precipitate during the titration techniques. In precipitation titration, the titrant, that is precipitating reagent, reacts with the analyte, that is halide, and forms an insoluble substance called as precipitate. That is when there is occurs chemical reaction between standard solution, that is titrant, and titrate, there is formation of precipitate takes place, and this formation of precipitate continues till the last movement of analyte, that is halide, is present in conical flask. Next, after this is the introductory part of precipitation titration. After introduction, next is the application. So precipitation type of titration is mainly used in determination of halides, that is chlorine, bromine and iodide ions, singly or in a mixture, that is the analyte may be present either as a single entity or it may be present as a mixture of entity by precipitating it with a standard precipitating reagent, that is silver salts. So this is the main application of precipitation titration. What is the basic principle? In basic principle, we are going to prepare standard solution of precipitating reagent, that is silver nitrate or ammonium thiocyanate. This nature of standard precipitating reagent varies depending upon the nature of analyte. After preparing the standard solution, we are going to fill up the standard solution into the burette. Nextly, we are going to add 1 ml of standard solution from burette to contents in conical flask containing solution form of analyte. In case of precipitation type of titration, the analyte would be chlorine, bromine, iodine as a single entity, or it may be present in a mixture form. And lastly, we are going to add indicator. When we are going to add 1 ml of standard solution of either silver nitrate or ammonium thiocyanate, there is formation of precipitate between the halide entity and standard solution of silver nitrate, and formation of insoluble precipitate takes place. So moment will come that no more halide entity will be present in conical flask to react with the precipitating agent. That point is known as end point of titration. So one more excess drop of standard solution will then react with the indicator, and color change of contents in conical flask will be identified or will be seen. At that moment, we will stop addition of standard solution, and from the volume of standard solution consumed by analyte, we will be able to find out the concentration of analyte. Next is the principle. It is the main principle of precipitation titration is that quantity of added precipitating reagent or precipitant is equivalent to substance being precipitate. So here substance being precipitate would be halide ion. जेवढं का halide conical फ्लास्क मध्ये प्रेझेंट असेल, halide whatever it may be, क्लोरीन असेल, ब्रोमिन असेल किंवा आयोडीन असेल, तेवढंच ते प्रेसिपिटेटिंग रिएजंट सोबत रिएक्ट होईल, and a point will come that no more analyte will be present in conical flask. At that moment, excess drop of precipitating reagent will react with indicator, and color change of contents in conical flask will occur. So precipitation type of titration is mainly based on the solubility product. जेवढं काय insoluble precipitate तयार होईल तेवढे त्याचे results हे जास्त असणार आहेत. So next point related to precipitation type of titration is the methods of precipitation titration. According to endpoint detection method, 3 main procedures are widely used depending upon the type of application, that is depending upon the nature of analyte. This precipitation type of titration is categorized into 3 classes: Mohs method, Wohlhertz method, and Furjans method. Let's see one by one. So first method of precipitation titration is the Mohs method. So in case of Mohs method, it is a precipitation titration in which silver ion, that is precipitating reagent, is used as a titrant, and chromate ion, that too potassium chromate, is used as an indicator in Mohs type of titration. So Mohs type of titration is a direct type of titration. Directly we are going to precipitate the standard solution of precipitating agent with that of the analyte. And this method is particularly applicable for quantitative analysis of halide ion, that is chlorine, bromine, and iodine. So these main 3 ions or halides can be determined by Mohs method of precipitation type of titration. In Mohs method of precipitation type of titration, most commonly used precipitating reagent is silver nitrate, indicator used is potassium chromate, and analyte would be either chlorine, bromine, or iodine. Next, in this method, sodium chloride, here we are going to consider example of analyte, that is sodium chloride, titrates with silver nitrate. Here silver nitrate will act as a precipitating agent. As silver nitrate solution, if we are going to add slowly from burette, which is to be added to contents in conical flask, that is sodium chloride, a precipitate of sodium chloride will be formed. So dropwise, when we are going to add standard solution of AgNO3 from burette to NaCl, that is analyte, which is present in conical flask, formation of precipitate between Ag entity of AgNO3, that is silver nitrate, and NaCl entity of sodium chloride entity will take place. So Ag will react with Na entity of NaCl, formation of AgCl, that is silver chloride precipitate takes place. This process occurs until all of the sodium entity of sodium chloride has been consumed by Ag. But a point will come when no more Na will be present in conical flask to react with Ag entity of precipitating agent. At that point, excess amount of Ag entity of precipitating agent will react with the chromate entity of potassium chromate, which is present in conical flask. This potassium chromate is an indicator. So excess drop of precipitating reagent will react with the chromate entity of indicator, and formation of silver chromate takes place. So end point of titration occurs when all of the chloride ions are precipitated, then additional silver ion reacts with the chromate entity of the indicator, potassium chromate, to form a reddish brown precipitate of the silver chromate. So end point of titration will be all of the all of the halide has been consumed by the precipitating agent, and excess amount of excess amount of precipitating reagent, that is Ag, will react with the chromate entity. Formation of silver chromate takes place. Next is the limitations of Mohs method. Mohs method is applicable in a pH range of only 6.5 to 10 only. 6.5 पेक्षा कमी किंवा 10 पेक्षा जास्त pH झाला जर contains in conical flask, तो results may get deviate. So below pH 6.5, there is increase in solubility of silver chromate. If we are going to perform the volumetric analysis, that is precipitation titration by Mohs method, below 6.5, there will be increase in solubility of silver chromate formed. And if we are going to perform the Mohs method above pH 10, the end point comes too late and it will consume more amount of standard solution, that is silver nitrate, and the results may get deviated, and silver hydroxide precipitate can also be formed. So this is the drawback or limitations of Mohs method. We have to perform the titrations in a limit of 6.5 to 10 pH only. If the pH is below 6.5, there is increase in solubility of silver chromate, and if the pH is above 10, there is formation of precipitate of silver hydroxide also, and the end point reached will be too late, and there will be excess consumption of standard precipitating agent. And if the solution is alkaline, next limitation of Mohs method, and if the solution is alkaline, we are going to make it acidic with the help of nitric acid. Then we are going to neutralize the excess of acidic condition by adding solution of either sodium bicarbonate or solution of either borax. So if the conditions are alkaline, we are going to make it acidic by adding nitric acid. Then we are going to neutralize it by adding solution of either sodium bicarbonate or borax. Another limitation of Mohs method is if appreciable amount of ammonium salts are present, the pH should not exceed 7.2. Say for example, if the analyte contains excess amount of ammonium salt, the pH may get extend over the 7. Therefore, we should maintain the pH in and between 7.2 range. Last limitation of Mohs method is in reverse titration, iodides and bromates cannot be titrated. Only chlorine can be titrated. So these are the limitations of Mohs method. So what is the basic principle of Mohs method? Mohs method is also known as direct method of precipitation titration. In Mohs method of precipitation titration, we are going to use silver nitrate as a precipitating agent. We are going to use chlorine, bromine or iodine as an analyte. And lastly, we are going to add indicator, that is potassium chromate is most commonly used indicator in case of Mohs method. Nextly, we are going to add 1 ml of standard solution from burette to contents in conical flask containing the analyte. After adding 1 ml of standard solution from burette to contents in conical flask, there is formation of precipitate between Ag entity of AgNO3 and Cl entity of NaCl. Formation of AgCl precipitate takes place. And lastly, when all of the chlorine has been consumed by precipitating reagent, that is silver nitrate, then excess amount of AgNO3, that is precipitating reagent, will react with the chromate entity of the indicator. Formation of silver chromate occurs. That will be the end point of titration. At the end point of titration, we will stop the addition of precipitating reagent, that is silver nitrate, from burette to contents in conical flask, and from the burette reading, that is volume of standard solution, that is silver nitrate consumed by sodium chloride, we can be able to find out the concentration of chloride. Second method of precipitation type of titration is the Wohlhertz method. So what is Wohlhertz method of precipitation titration? It is a precipitation titration in which silver ion is precipitated by another precipitating entity, that is ammonium thiocyanate, and in presence of ferric ions as an indicator. And that too, we are going to perform the Wohlhertz method of precipitation type of titration in acidic medium. So this is the basic principle of Wohlhertz method of analysis. So in case of Wohlhertz method of analysis, firstly, we are going to add excess amount of silver nitrate to the analyte, that is chlorine, bromine or iodine. Whatever the amount of chlorine will be present in that analyte, that will get react with the Ag entity of silver nitrate, and The unreacted or excess amount of silver nitrate is then back titrated with the second precipitating reagent, that is ammonium thiocyanate. And in case of Wohlhert's method of analysis, ferric ion is used as an indicator. And we are going to perform the Wohlhert's method of analysis in acidic medium. So these are the basic criteria for Wohlhert's method of precipitation titration. And this method is used to determine either concentration of halide, and it is also used to determine the concentration of Ag entity present in silver nitride. Nextly, in this method, there is formation of colored complex at the end point. So silver ion is titrated with thiocyanate ion in acidic solution using ferric ion as an indicator. So जेवढं काय firstly, in case of Wohlhert's method of analysis, content in burette will be standard solution of ammonium thiocyanate, and content in conical flask will be the analyte, that is halide. Next to that, we are going to add water in order to make the solution aqueous. Nextly, we are going to add excess amount of second precipitating reagent, that is silver nitrate. And lastly, we are going to add indicator. In case of Wohlhert's method of analysis, ferric ion is used as an indicator. Initially, contents in conical flask will be analyte plus standard solution, standard and excess solution of silver nitrate. त्याच्यामध्ये analyte म्हणजे halide जेवढं काय present असेल, that will get react with the Ag entity of silver nitrate, and formation of AgCl, AgBr or AgI precipitate will takes place. And unreacted and excess form of Ag, we are going to back titrate with second standard solution, that is ammonium thiocyanate. So initially silver thiocyanate is precipitate out due to the reaction between standard solution, that is thiocyanate and Ag. And after the equivalence point, when all of the Ag has been consumed by thiocyanate, when no Ag is present in conical flask, the excess of the thiocyanate entity, which we are going to add 1 ml from burette to contents in conical flask, will react with the ion entity, that is indicator entity, to give reddish brown ferric thiocyanate precipitate. So that will be the end point of titration in Wohlhert's method of analysis. So what is the basic principle in Wohlhert's method of analysis? It is particularly used for determination of halides, either in the form of chlorine, bromine or iodine. Along with halides, we can also be able to determine the concentration of silver. In case of Wohlhert's method of analysis, we are going to use two standard solutions. One which is present in conical flask, that is silver nitrate. Another which is to be filled into the burette, that is ammonium thiocyanate. Firstly, in conical flask, there will be the, we are going to add analyte, that is either chlorine, bromine or iodine. Nextly, we are going to add solvent in order to make the condition aqueous. Nextly, we are going to add excess amount of precipitating reagent, that is AgNO3. Lastly, we are going to add indicator. In case of Wohlhert's method of analysis, ferric ion is used as an indicator. So initially, since we are going to add standard solution of precipitating reagent into conical flask itself, there is formation of precipitate between the analyte, that is halide ion, and standard solution of AgNO3. A point will come that no more analyte, that is halide, will be present in conical flask to react with the AgNO3. So excess amount of Ag is then back titrated with the ammonium thiocyanate, which is filled into the burette. So जेवढं काय excess amount किंवा remaining amount आहे silverचं, that will get react with the thiocyanate entity. When all of the silver has been consumed by thiocyanate entity, then excess amount of thiocyanate entity will then react with the ferric entity of the indicator, and formation of complex between the thiocyanate and ferric entity takes place. That indicates the end point of titration. Next is the modified Wohlhert's method. In case of modified Wohlhert's method, we are going to add extra reagent in titration process. So extra reagent used is dibutyl phthalate. So modified Wohlhert's method, it is also known as cold wells method, and it is specially used for determining the concentration of sodium chloride and potassium chloride. So in case of chloride, it is usual to filter of the silver chloride or coagulate the precipitate by means of either dibutyl phthalate preferred or nitrobenzene. So these are the two extra solvents used in modified Wohlhert's method. So in case of modified Wohlhert's method, firstly there is formation of reaction it is same as that of Wohlhertz method. Only we are going to add two extra reagent, that is dibutyl phthalate or nitrobenzene, in order to coagulate or in order to separate out the two precipitates. That is, two precipitates form will be, one is AgCl due to the reaction between first precipitating reagent, that is AgNO3, and NaCl. Formation of AgCl precipitate takes place. Second precipitate is due to the reaction between excess amount of Ag and ammonium thiocyanate. So in order to distinguish in between these two precipitate, modified Wohlhertz method is used. In case of modified Wohlhertz method, these two reagents, that is dibutyl phthalate and nitrobenzene, will differentiate out two different precipitate. So what is the use of these two? So dibutyl phthalate and nitrobenzene, it will either we are going to separate out two precipitate either by filtration process or by using the reagent. The reagent will coagulate the first precipitate, that is AgCl, and the excess of silver nitrate which is present in conical flask is then back titrated with potassium or ammonium thiocyanate using ferric ferric alum as an indicator. The nitrobenzene or dibutyl phthalate is added to coagulate the silver chloride precipitate so that it will not interfere with the titration of excess of silver nitrate by forming a layer over silver chloride, and this will avoids the need of filtration. Best example is by preparing modified Wohlhertz method can be done by preparing 0.1 molar of ammonium thiocyanate. Next is last method of precipitation titration is the Furjans method. So in Furjans precipitation titration method, in which silver ions is titrated with the halide or thiocyanate ions in presence of adsorption indicator, that is known as Furjans method. So in case of Furjans method, we are going to use either silver nitrate as a precipitating agent, or we are going to either use ammonium thiocyanate as a precipitating reagent that will form precipitate with the halide ion. Halide may be either chlorine, bromine, or iodine, and we are going to use adsorption indicator in case of Furjans method. And this method is generally used for quantitative analysis of halide ions or thiocyanate ions. So Furjans method is based upon use of adsorption of indicator. What do you mean by adsorption? That is adherence of indicator on the surface of precipitate which is formed between analyte and precipitating reagent. So adsorption point will come that no more analyte will be present in conical flask to react with standard reagent. At that moment, the indicator which is present in conical flask that will get adhere over the formed precipitate and color change occurs. That indicates the end point of titration. So absorption of indicators are absorbed by the precipitates, that is AgCl, and during the process of absorption, changes occurs in the indicator which leads to substance of different color. Hence, they are termed as adsorption indicator. Initially, into the conical flask, the analyte, solvent, and indicator, they are dispersed. But when we are going to add 1 ml of precipitating agent from burette to contents in conical flask, there is formation of precipitate between the precipitating reagent and analyte. And due to formation of a reaction between precipitating agent and analyte, or the analyte will get converted into insoluble form or precipitate form. So the indicator which is dispersed into the conical flask, that will get adhere over the precipitate and color change occurs. That indicates the end point of titration. And the indicator used in case of Furjans method of analysis is the fluoroscene and its derivatives. They are adsorbed to the surface of precipitate, say for example AgCl, and after all the chlorine is used, the first drop of Ag, that is excess which we are going to add from burette, will react with the fluoroscene forming a reddish color. That will indicate the end point of titration, that is excess amount of precipitating reagent from burette will react with the fluoroscene, that is F entity of the indicator. Formation of complex, that is AgF, takes place and color change occurs, that is reddish brown color occurs. That indicates the end point of titration. Next example of indicator used in case of Furjans method of analysis is the EOC. it is but a color change in for eosin, it is from pink to red violet, and it is particularly used for determination of the drug substances containing fluorine, and it is to be used in a pH of less than 1. Third example of indicator used in case of Furjans method of analysis is diiodo-dimethyl fluorosine. Color change for this indicator is from orange to blue, and it is particularly used for determination of the analyte, that is iodine, and it works only in pH between 4 to 7. And fourth and last indicator used in case of Furjans method of analysis is dichlorofluorosine. Color change for this indicator is from yellow to green. Sorry, yellow green to red, and it is particularly used for determination of analyte, that is chlorine and bromine, and it works in a pH range of 4 to 7. So these are the 4 indicators used in Furjans method of analysis. What is the basic principle of Furjans method of analysis? In Furjans method of analysis, we are going to determine the concentration of halide either in the form of chlorine, bromine, or iodine. Thiocyanate concentration can also be determined by Furjans method of analysis. In burette, there will be standard solution of silver ions or standard solution of ammonium thiocyanate. When we are going to add 1 ml of standard solution of precipitating reagent from burette to contents in conical flask, there is formation of precipitate between Ag and halide entity which is present in conical flask. So all of the analyte will get converted into precipitate form. Due to the conversion of analyte into precipitate form, there is adsorption of indicator over the formed precipitate and color change occurs. So when color change occurs due to the reaction of excess drop of standard precipitating reagent, when we are going to add it from burette to contents in conical flask, and fluorescent entity of indicator and formation of AGF takes place. That is indicated by the color change, that is formation of reddish brown. Other than fluorescent, these 3 indicators are used in case of Furjans method of analysis, that is eosin, diiodomethylfluorosine, and dichlorofluorosine. So this is the third type of precipitation type of titration, that is Furjans method. Next is the comparison of precipitation titration, that is what are the advantages of Mohs method, disadvantage of Mohs method, what are the advantages and disadvantages of Furjans method, and what are the advantages and disadvantages of Wohlhert's method. So Mohs method, it is more simpler one since it is a direct type of titration. No extra reagent is required. Disadvantage, we have to maintain the condition alkaline. It is not suitable for determination of the analyte, that is iodide, and there requires a determination of blank, that is performing the titration without the analyte by maintaining the condition similar as that for the analyte. So these are the advantages and disadvantages. Advantage ka, it is simple and direct method. Disadvantage ka, we have to maintain the condition alkaline. It is not useful for determination of iodide, and we have to perform a blank determination. Second method of precipitation titration, that is Furjan. Its advantage, it is the capability for different pH ranges. That is, we can perform it over a wide range of pH and selectively with different indicators. That is, wide range of indicators can be used. Disadvantage ka, it is difficult to analyze the analyte with dilute solution and should not be a high background ionic level. जर ionic level जास्त असतील तर end point cannot be determined in case of Furjan's method of precipitation titration. Third method of precipitation titration is the Wohlhert's method. Advantage ka, it is capable of direct silver and indirect halide analysis. We can be able to find out the concentration of silver and other halide analysis, and very clear color change can be occurred at the end point of titration. These are the 2 advantages of Wohlhert's method. Disadvantage ka, there must be addition of 1 molar of nitric acid solution while performing Wohlhert's method of analysis, and some problems with specific anions, that is due to the adsorption of the indicators, some anions may interfere the determination of endpoint of titration. Last is the limitation of precipitation titration. A few number of ions such as halide ion, that is chlorine, bromine, or iodine can be titrated by precipitation titration. दुसरे halide ions आपण precipitation type of titration ने determine करू शकत नाहीत. Only these three can be determined. There may be formation of co-precipitation occurs during titration process, and it is very difficult to determine the endpoint if there is no distinct color change occurs. So these are the limitations of precipitation type of titration. It is applicable only for determination of these three halide ions. Co-precipitation may occur during formation of precipitate. What is co-precipitation? That is precipitation containing impurities. Impurities may get adhered to the precipitate between precipitating reagent and halide ion. That will interfere the burette reading, and obviously it will interfere the results of analysis. And it is very difficult to detect the endpoint if selection of indicator is not distinct one. So these are the limitations of precipitation type of titration. So with this, we have completed the last chapter of third unit, that is precipitation titration.